Okay, looks like we're recording, so let's go ahead and get started. Going to have some interesting things that I hope work out today. We'll see. So there's always potentially technical difficulties, but we'll see. So let's take a look at the question of the day. So this was interesting, where people are. I'm very interested that there's so many of you who are on campus. That's very interesting to me. A good number who are not even in the United States, which we kind of know. So that was interesting to see the results for that. So today what I'm going to be talking about is interfaces. We've been talking about them for several lectures now. I want to kind of give you a better understanding. We're going to actually write an interface, so we'll see what's involved in making an interface. I usually do something, when I have an audience, I do something that to set up the lecture to be able to refer to it later. And I can't quite do it, but I'll mention it anyway, because I think it's a useful thing to be thinking about. I say, pretend that I'm some old guy who doesn't understand modern technology, and actually that's not such a stretch. It's not so hard to imagine, because it's somewhat true. So I say someone who's really out of date, that they have a TV at their house. I mean, you may not realize that this was true, but in the olden days, TVs often had places to plug things in where it would say something like cable. You plug in your cable box here, or DVD. You plug in your DVD player here. So suppose this is some guy, who's got the old TV where he's plugged in his cable box, he's plugged in his DVD player, where it's said to plug them in. And he's wondering whether he should get a new TV. Every time he goes to Costco, he sees all those big TVs out there. He's wondering whether he should get one. And he goes and he looks at the back of the TVs, and they're confusing because there's no place that says cable and no place that says DVD. They seem to have these things that say HDMI 1, HDMI 2, HDMI 3. And what's an HDMI? I might tell you, I don't know if I even have any HDMIs. I mean, I have a DVD player, I have a cable box, but if I go to Best Buy, I can find an aisle where there are DVD players, radios, all sorts of things, but there's no aisle that seems to be labeled HDMI. What are these things? Do I have to buy one? Is it going to be able to play my DVDs? Is it going to be able to connect to my cable channels? What the heck is an HDMI? So anyway, I get interesting answers from the audience to try to explain this. And we don't have the opportunity to do that, so I'll just kind of, cut to the end and talk about it. So, one thing to think about is, do you know what the HDMI acronym stands for? And I believe it's High Definition Multimedia Interface. So HDMI is an interface. And what I usually get students who do a pretty good job of trying to explain that a DVD player can also be an HDMI device. That the idea is that we want to have a standard kind of interface so that the DVD player can produce an HDMI signal, the cable box can produce an HDMI signal. All of these devices that we want to plug into the TV could potentially produce an HDMI signal. If there's something that's not producing it now, then the problem becomes things like, how do you convert, or there's special cords you need or something in order to convert this into HDMI, because these, as the guy would have noticed at Costco, these devices are all assuming you're plugging in HDMI devices. And then, so one of the things to think about is, well then, is the DVD player a DVD player, or is it an HDMI device? And I think the right answer to that question is, it's both. So implementing an interface, kind of satisfying an interface, means that you can be thought of in two different ways. I mean, it's clearly a DVD player. That's a very complex thing. A DVD is a very complex device. The HDMI interface is a rather simple thing. But basically we would say that this DVD player is both. It's both a DVD player and a device, an HDMI compliant device. So we would think of it as being of both of those types. And that's all of that kind of relates to the way it works in Java. It actually corresponds very neatly to the way it works in Java. Well, so I've got some code I wanted to show you as an example. It's kind of silly code, but that's fine. I mean, that's not the point. The point is to think about how to make this code work in the way that I want it to work. So I'm setting up an array int list here, and I do some various things to it. I'm setting up a linked int list. Now, we're going to talk about linked lists next week, and we'll be talking about how to implement linked int list, which is going to be a parallel to array int list. So, we've been using array int list as our case study. We'll do linked int list as well, so we understand that variation. And we are doing this as a way of understanding the built-in array list of E, and there's a built-in linked list of E. We saw that with our Q code that we wrote last time, is that there's a built-in thing called linked list of E, and we're going to study linked int list as a way of understanding how linked list of E works. Now, I have here linked int list. I put a bunch of blank lines in here because I basically don't want to talk about the implementation today. That's next week. So that's just a bunch of blank lines because I didn't, but there's code. There's actual stuff in this class. And for the array int list, I went back to a simplified version of it that's, I think, it's actually even a little simpler than what we ended with last week. I wanted to keep it simple because you're going to see that I want to have a connection to the linked int list class. So in any event, it's kind of a slightly stripped down version relative to what we've been seeing recently, but it works. It's an array, the array int list works. If I go here and I compile this code, it works. This code sets up an array int list that then, we get a couple of lines of output because we add 3 things and print, we remove something and print again, and we do the exact same thing with our linked int list, with the same commands, parallel commands, and the same kind of thing happens. It sets up a list that's length 3, it gets rid of the value that's at index 1, and we're left with the 1893. Okay. So that's where I want to start. Those of you who took 142 from us, your 142's instincts should kick in and should tell you this is horrible code, this is very redundant, too much code in main, and so forth. So we don't want to have code like this appear twice. So let me make a copy of that code. What we'd want to do is to have a public static void method. How about if we call it process list? And I could give it an array int list that I'll call list. I'll use just kind of a generic name. And I'm going to go here and paste in all those lines of code. And so now, since I'm using a more generic parameter name like list, which I think is the right way to go, then I'm not going to call it list1 anymore. So we'll just change all the list1s to list. So we put it into a parameter, and have it do otherwise the same stuff. And what that's going to allow us to do is that we can remove all of these detailed lines of code in main and replace it with process list. And we can do it the second time. So we get rid of the redundancy. Not only are we making main shorter and more concise, but we're also getting rid of the redundancy. Process list. So we'll call that twice. Once on the list 1, once on the list 2. So let me go ahead and compile that. And it gives me an error message, incompatible types. So it's complaining about the second call. Incompatible types, linked int list cannot be converted to array int list. Oh, this parameter was of type array int list. And so it says it can't pass list 2. Okay, so then the compiler wants me to change this to linked int list. The compiler always knows best, so we'll do what the compiler says. And we compile. Oh, now the compiler says incompatible types array int list. So now it wants me to change it to array int list. So we could do that, and we could compile. And now it's complaining about linked int list again. Make up your mind. Anyway, it's a joke. So the compiler doesn't know what we should do. It's just complaining. So the point here is that we can't do what we wanted to do here. We can't write the generic method that can be used for both kinds of structures. So this is why we're going to want to introduce an interface. And let me, so let me go ahead and what I'm going to do, well, I wanted to describe an idea that I have for how to think about what an interface is. So we talked about the idea of radios. You know, you could go and buy a radio, and it has various controls on the outside of the shell. You know, there might be knobs and buttons and displays and so forth. But I've talked about the idea of prying open the radio and seeing what's inside, the implementation, all of the guts of what makes it work. Well, I have an analogy for what an interface is like, that it's a little bit like if we took a radio like that, pried it open, and we just scooped out all of the guts and set them aside. We just take away all of the implementation details. We take away all of the things that make it work and kind of seal it back up again. And so you have this radio that has buttons and dials and so forth, but they don't do anything. It's a hollow object. It's an object that doesn't have the stuff inside that makes these things work, but you can see it has an on-off switch. It has a knob you can turn to change the station. It has another knob you can turn to change the volume. So you get to see kind of how it's controlled, but none of those controls have been implemented. There's nothing inside. So that's an analogy I have for what to think about, how to think about an interface. And I'm going to kind of do that. So I've got this array IntList here. I want us to have an IntList interface. This is going to be like the built-in list of E that we've seen that exists. So we're going to make something called IntList. It's not going to be a class. It's going to be an interface. So we use a different word in the header. Notice it's purple. JGrasp recognizes that that's a built-in Java keyword. So we're going to make an IntList interface. And I'm going to do just what I described. You know, I'm prying it open here. I'm going to pull out all of the guts. So interfaces don't have fields because that's actually an implementation detail about how it's done. They don't have constructors, so we can kind of get rid of all of this constructor code here. But we do want to kind of remember the fact that it has a method called size. We don't want to have the implementation for the size method, so I'm going to get rid of that. We want to remember that it has a method called get, but we don't want the implementation of the get method. We know it has a toString because everything has a toString, but we can just kind of do the same thing here. If we were writing a description of this, we might explain that there are some requirements about the toString, that the toString displays things in square brackets with commas in between. We want to remember that there's an index of, but we don't want to remember how it's done. So we want to kind of get rid of that implementation part. We want to remember that there's an appending add that takes one int, but we don't want to remember how it's done. We want to remember that there's an add that takes two ints that adds at an index. We want to remember that such a method exists, but we don't want to have the details of how it's done. We want to remember that there's a method that removes at an index, but we don't want to know how it's done. And there were some private methods, and private methods are absolutely part of the implementation, not something that should be visible from the outside. So I just got rid of them. So I've kind of stripped this down to the outer shell, what a client would see. A client would know that these are methods that can be called, and that's, you know, that's how I did your homework one, is there was a table of methods. And so I said, these are various methods a client is going to expect that your class has available to the client, and here's a description of what it does. So this is kind of what the client wants to know. What are the different methods that are going to be available to the client? Now, in the case of a class, we had an open curly brace here because then we had some lines of code and a closed curly brace. That combination is sometimes called the body of the method, or a block, you know, inside of the curly braces. It's known as a block. But that's not what we do when we have an interface. When we have an interface, we don't have any of that, but we want something here, and so the decision is to have a semicolon instead. So instead of a block, a set of curly braces with code inside, we have a semicolon. That's what we do in an interface. That's a convention that was borrowed from C. In C, these are known as function prototypes. So it's just kind of the header of the function without any of the details of how it's implemented. C calls them functions, we call them methods, but it's the same thing. So that's how we make an interface, is we kind of list all of the different methods that we're going to want to, that we require, for this interface, but none of the implementation. All of the bodies have been replaced with semicolons. There's no fields, there's no details, no constructors that make it work. I'm going to say save as to save this, and it knows to save it as intlist.java, which is good. So I'll go ahead and say save, and then let's try compiling it to make sure that it compiles. Great. So now we have a way of kind of describing a more generic version of it, IntList. So that means that I can come over here and I can change this to be IntList, right? Because that was what I was that's what I was looking for, was something that would allow me to refer to either of the two lists. So IntList is the way to do that in a generic way, right? The interface way. So let me hit compile. And now what it says is that both of them are incompatible types. So I've doubled the errors. So now it won't let me make either of the two calls. Array IntList is incompatible and linked IntList is incompatible. Well, okay, so what's going on here is that Java is very picky about the types of objects. So Java wants you to be very clear about what are the different types of an object. And so if something is going to be considered to be of type IntList, you have to let Java know that that thing is going to be considered to be of type IntList. I think I closed my array IntList because I replaced my array. I kind of turned the array IntList into the IntList interface. So let me open again my array IntList. So I have that available to me. So in the header of a class, we've seen in the 142 class, you gave commands like extends critter, and that set up what we call an inheritance relationship. We're going to talk more about inheritance later. So you can have an extends clause in the header of a class. Java only allows you to have one inheritance relationship. So if you're going to have an extends clause, an inheritance relationship, there can be only one. We could say something like that. I'm going to leave it in for a second just to make a point, but obviously we're not trying to connect this to critter, so I'm going to get rid of that in a minute. But I wanted to point out that you can have an extends clause, and there's another kind of clause where you can say implements. Notice that extends and implements are both in purple. JGrass recognizes that these are built-in Java words. So you can say that this implements the IntList interface. And now you can only have one inheritance relationship, so there can only be one thing listed with an extends clause. But with an implements clause, you can say this, and then another one, and then another one, as many as you want. You can implement as many interfaces as you want. So this is another nice thing about interfaces, is that classes have the ability to implement more than one interface. We've seen this because we know that linked list implements list of E just the way array list does. These are the built-in ones. Linked list of E in the Java class libraries implements list of E just the way array list of E does, but it also implements queue of E. Remember from last time. So a linked list implements both of those interfaces. So a class can implement more than one interface, in which case you separate them with a comma. So that's a nice thing about interfaces. Let me get rid of the extends critter because I didn't really want to be doing that here. Well, as I said, we'll talk a little more about inheritance later. There's a funny way in which inheritance is almost the opposite of an interface. When you say something like that, extends critter, that means that this class automatically has some state and behavior that it gets from the class it's inheriting from. We'll describe that later. If you didn't do a lot with inheritance prior, that's okay. We'll we'll review that when we get to it. But an interface, I've said that it's a little bit like the concept of certification. So that if you're saying that you implement IntList, you're saying you're a certified IntList. So imagine, we use this term for things like if you want to be a certified accountant, you have to study a lot. There's a whole lot of things you have to know in order to be considered a certified accountant. What if you wanted to also be a certified real estate broker? Well, there's a lot of other stuff you have to learn in order to qualify as a certified real estate broker. So kind of the more things that get listed here, the more constraints that puts on you. Inheritance is different. Inheritance actually gives you something for free, whereas interfaces give you requirements or constraints. Well, let me show it to you in the following way. We're going to be using this class Friday. I'm going to do a different example with you in a minute. But let me just kind of show you what would happen if I said implements IntList. This is not a class that implements the IntList interface. The IntList interface had all these different methods here. So if I go over here to this Friday class and I claim that it implements the IntList, let's see what happens when we try to do that. So I'm going to say compile, and it says Fry is not abstract and does not override abstract method remove of int in IntList. So it's saying you aren't allowed to claim to do this because you don't have a remove method that takes an int as a parameter. It's kind of interesting. You might notice remove was the last thing that was listed in the interface. There seems to be a stack-like thing going on here, and I think that what you find is that if you added an implementation, you added a remove method, remove it in int, the next thing it would complain about is this. So it seems to be some kind of a stack-like behavior where it kind of does these things in reverse order. But it would require you to have all of those methods. So Java doesn't let you claim something that's not true. So if you claim to implement an interface, it'll make you honest. It'll make sure that you actually do implement that interface. So you can't just say that, that you implement an interface when you don't. But our array IntList really does implement the IntList interface. Well, we know it does because we made the interface by getting these things straight out of the array IntList itself. It had all those methods. So we know that that's actually appropriate. We're not going to have it implement other interfaces, so let me get rid of this. We just wanted to say that it implements IntList. So let me hit compile, and it compiled, which is good. So I haven't shown you linked IntList, so you don't know for sure, but I'll let you know it actually does have all of those methods, and we're going to be spending time next week talking about how would you implement these different methods, the appending add, the add and an index, the get method, and so forth. But I'm going to go ahead and add that notation in the header, implements IntList, so that it also claims to implement the IntList interface, and let's see if it compiles. And it did. So that meant that Java looked to make sure that all of these different methods that are mentioned here are part of linked IntList. Now, it had it to string no matter what, so it didn't kind of do anything to check on that because we know that's a built-in thing. But it made sure it had all of the other methods, and it did because when I hit compile, it compiled. So now I have told Java that linked IntList implements IntList and that array IntList implements IntList. So let's see what happens when I come over here and I hit compile. Now it compiled. So one of the things, I said that if you were trying to explain this concept of HDMI, to somebody who wasn't familiar with it, that one of the things that you would say is that a DVD player is of two types in a sense. It is a DVD player, it's of that type, but it's also an HDMI device. So you could think of it as an HDMI device as well. If someone make up your mind, well, it's both. It really is both of those things. It's something that can be plugged into an HDMI slot on one of those TVs at Costco, and it's a DVD player. Well, so that's really what we're saying here in the header, is that the linked IntList is a class, a very specific kind of class, and so a linked IntList can be considered to be of type linked IntList, but it also can be considered to be of type IntList. And that's why when I wrote code here that passed an array IntList into something of type IntList, that worked. Those are compatible types. So interfaces kind of give you this ability to be able to write one method that can be used for either. Well, again, if I had an audience, I'd ask you guys, do you see anything here that's potentially an issue? And people are usually pretty good about saying, well, wait a second. If we've now defined an IntList interface, if that's available to us, then we don't want this variable to be of type array IntList anymore. One of the style issues that I mentioned is that we want you to use interfaces whenever possible. So instead of this being array IntList for the variable and linked IntList, we're just going to say IntList. So for variables, remember there's 4 places where you can use an interface. In the variable type, in the type of a field, the type of a parameter, and the return type of a method. So those 4 places, we expect you to use interfaces when you can. Now, obviously here, when we go to constructed, we have to make an actual object. So that's why we say array IntList or linked IntList here. Let me make sure this still compiles. And we can just run it, and we'll see that it kind of does the right thing. I think I typed in a straight character down there that I didn't mean to. Let me mention a few more things. So one of the things to know about this variable list1, well, this variable list1 is more like one of those HDMI 1, HDMI 2, those different places on the TV where you can plug something in. You know, I'm saying that list1 is something where I can plug in an array int list, but I could also unplug that and plug in a linked int list. So I could do something like this, and then I could say list1 is going to be reassigned to be a new linked int list. So I can, you know, it really is just like that concept of the HDMI port on a TV, where you can plug in a DVD player if it's HDMI compliant, and then you can unplug it and plug in a cable box if it's HDMI compliant. So we can plug in different devices at different times. That's a flexibility that this interface gets us. Well, and that's what we have here with this variable list1. I can plug in an array int list at one point in time, have it do various things, and then later I can kind of unplug that and plug in a linked int list. So I can plug in different things as long as they implement the int list interface. So it really is a direct parallel of that HDMI idea and that idea of having a flexible HDMI port where any HDMI device can be plugged in. The fact that they do it on TVs is a good indication. You're getting a sense of why do we want to do this, because it makes the TV more flexible. So that's what this variable list1 is, more flexible because we can do this. I don't remember whether I compiled. Let me just compile to show you that that works. I wanted to show you one more. What if I said list1 is a new int list? So on the right-hand side, instead of saying array int list or linked int list, I'm saying the interface type, int list. Well, let's see what happens when I hit compile. When I hit compile, it says error, int list is abstract, cannot be instantiated. You're not allowed to ask for new things to an instance of, that's instantiating. I can't create an instance of an interface because an interface is an abstraction. I kind of think of this as being a little bit like, what if I went to Best Buy? So I know what a radio is. Other people know what a radio is. I took a look on the Best Buy site this morning, and they sell radios. So look, there's a nice Insignia radio here. There's a Sony radio here. They sell a lot of Sonys, Insignias, Crosley, different kinds of radios that you could buy. So I kind of imagine going to Best Buy, but radio is the abstraction. We even talked about what kinds of things would be included in a radio interface. You know, that there'd be an on-off button, whatever. We were making a list of behaviors that we expect of a radio. But that's just an abstraction, a radio. It's a concept that we have. We have a notion of what a radio is. So what if I went to Best Buy and I said, I'm looking to buy a brand new radio? And the salesperson said, well, we have a nice Sony over here. No, I don't want a specific one. I want radio. You want an Insignia? It's a Best Buy brand. No, radio. I don't want a specific one. I want the abstraction radio. I want to buy that. And I guess I kind of imagine that a well-informed salesperson would say something like, radio is abstract, cannot be instantiated. I can't sell you the abstraction radio. I can sell you a specific kind, a Sony, specific kind of radio. I can sell you this kind of radio, a very specific radio, but I can't sell you the abstraction. You can't make a new abstraction. It's not an object. It's hollow. How's Java supposed to follow that blueprint and make something that works? It can't. So it's useful to understand you are not allowed to create an instance of an interface. Okay, so I usually ask if there's questions, but we don't have that opportunity. Maybe you'll use the Q&A to do that. I wanted to show you one more thing before I talk to you about the homework assignment. So I've got a little class here. I'm going to do something with the point class that's part of the AWT package. This was with graphics. Don't, if you didn't do graphics with us, you didn't do AWT, don't worry about it. There's a notion of a point with XY coordinates, and I use that in Chapter 8 as the example of implementing a class. What I wanted to do here is I wanted to talk about the idea of dealing with an array of objects, because you're going to have to do that in your homework assignment. So I'm basically doing this little example here. It's very simple, but I just want you to, I want to remind you of some things that are relevant when you're dealing with an array of objects. Maybe some of you already know all of this, and that would be fine, but I just want to make sure we've reviewed this notion. So there is this class called point that's part of the AWT package for storing XY coordinates, screen coordinates, if you're doing graphics. What if I wanted an array of those? So suppose I was going to have something called points, which was a new point array, say, that had 5 things in it. If I execute this line of code, am I going to have any point objects? Is kind of the question. The answer is no. I'm going to set a stop there on that line, use the debug option, let that kind of use the little step function to let that line of code execute, and then I'm going to drag out points to see what's in this thing. So let's take a look. Make this kind of big because we're going to do some other things in a minute. But here's my array that's 5 long, and it's got these little blocks in there, block, 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 block. It turns out that what's in stored in those different cells is the value null. So I've talked about the idea that when an array is constructed by Java, it auto-initializes it to the 0 equivalent of the type. Well, the 0 equivalent of a class, of an object like point, is null. And we don't talk a lot about null in the 142 class, but we're going to be talking about it a lot more, particularly next week. Null is a special value that kind of means no object. You could almost think of it as being the object, the reference equivalent of a 0, no reference, that it's a reference to nothing. So when I construct the array, I get the array, but not the individual point objects. If I wanted individual point objects, I'd have to say something like, for int I equals 0, I less than points.length, I plus plus. How about if we set points of I to be a new point? How about if we set it to 2 times I and 2 times I plus 1? Just to have something stored in those different point objects. Let me go ahead and end this execution. Let me recompile and debug again. And we'll let it set up the array, and we've got those null values, but now it's going to go in this for loop. So it initializes an I to 0, and so it's going to be setting points of 0 to be 2 times 0 and 2 times 0 plus 1. So let me go ahead and let that line of code execute, and it made a little point object here. How about if we go to our viewer settings and we make this wider so we can kind of see, there's our 0, 1. That it made a point that's got an x and a y of 0 and 1. And then it comes back around the for loop. I is incremented to be 1, and then it sets up points of 1. Comes back around the for loop, I becomes 2, and it sets up points of 2. Comes back around the for loop, and it sets up points of 3. Comes back around the for loop, and it sets up points of 4. So the important thing to understand from this is that when you go to construct an array of objects, you have to construct not only the array, but each individual object that the array is going to refer to. So how many objects in total did I construct here? I often trick people into saying 5 because they think of the 5 points, but there's really 6 objects that I constructed. I constructed the array that stores references to the 5-point objects I constructed. So it's a 2-step process, setting up an array of objects, constructing the array to hold the references, and then constructing the actual objects. And just to remind you that there are these for each loops that you can use. We don't need to do another debug. We can get rid of that. So the for each loop is available for arrays, including arrays of objects. So remember, with the for each loop, you have to say what kind of object you have. So it's going to be a point object inside of this array. And you can use any name you want. I often use a simple name like P, but you could call it the point. You could call it, next. You could call it foo. You could call it Fred. I mean, whatever you want. I'm going to call it P. For all of the points P that are in the points array, I could do something like a system.out.println of P. So I'm just doing this to remind you that that for each loop is available to you when you have an array of objects, and you're going to be manipulating an array of objects in your homework assignment, so there are places where you might want to write a for each loop. So I'm just kind of reminding you that. This will be on the calendar for today, this little point example. All right, well, I want to spend the last bit of time here talking about the homework assignment. So I've posted this on the homework page. This assignment, I mentioned you're going to get some minor practice with queues, but this is not a queue assignment. This is an object assignment where you're going to be kind of getting used to dealing with multiple classes and interfaces and different kinds of objects and code written by someone else. So this is a whole lot more like the 142 critter assignment. What I tell my students when I give out critter is that an object assignment like this seems to have a different aspect to it. That often with a programming assignment, you spend something like 4 or 5 hours reading the assignment write-up and figuring out, you spend an hour reading the assignment write-up, figuring out what you're supposed to do, and then 4 or 5 hours writing the code, because there's a lot of code, it's tricky, there's bugs and so forth. But with these object type assignments, it's kind of almost the other way, where you spend 4 or 5 hours on the assignment write-up and then only an hour writing the actual code. This one could be a little bit like this. I think you're going to find that the real work here is in reading the description, understanding this code universe in which you're going to be writing things, understanding what these different methods do. As a result, this is really not a good assignment to do late. You want to work on this early so that you have plenty of opportunity to go to TA office hours and get questions answered if you're confused about any of this. Let's take a look at the specification. So there's a description here. I went to a computer science education conference, I guess about 10 years ago, I think. And this fellow, Kevin Wayne, was presenting. He's from Princeton. Great guy, interesting guy. Very music-oriented. He plays piano. And anyway, Kevin showed this assignment. He described this thing that he'd given to students at Princeton. And he had his computer making really, very beautiful sounds. And I thought this seemed like a cool assignment, something I'd want to do. So when I got back here, I read the assignment write-up, that he had, and I was like, I don't get it. I read it again, and I'm like, I don't see how that does what it's supposed to do. Anyway, I had to have a kind of a suspension of disbelief. Eventually what I decided to do was that I would just do what it told me to do and see what I got. And it turned out I got beautiful sound coming from my computer. So an interesting thing, so this one has to do with sound, and I would say that I've learned things about hearing and sound by working on this assignment, but I still don't understand them very well. They're still pretty, so there's, a lot of physics behind all of this, and also physiology of how the ear works. But so in a way, I actually think this is a feature, not a bug. It's often the case that programmers are working with people who have domain expertise, and they say, here's what I want you to do. I want you to write code that does this and this and this. And you say, well, I don't see how that's going to work. Never mind what you think, just do what I said. So that, it may end up being like that. You may be like me. You won't understand why it's going to do what it does, but you just do it to kind of see how it turns out. How about if I show this to you? Let me show you a version of this running. So there's a program here called Guitar Hero where I'm constructing what's known as a guitar light object. So let me compile and run this one. One of the ideas we're going to have here is that there can be different kinds of guitars. This particular guitar has 2 strings, an A and a C, and not anything else. But I should be able to hit the A string or the C string. So the result of what we implemented, allowed me to have that little guitar there that was making those sounds. All right, let's go back to the assignment write-up and take a look. The first part of the assignment write-up, you are going to be implementing a class for an individual guitar string. So that's kind of the first part, is to implement something that simulates a guitar string. Now, in doing so, you're going to fill up a structure with random numbers. This is kind of a bit of what we would call white noise. And in creating these guitar string objects, you're going to have sequences of different lengths. So suppose you had a very short sequence. There's a certain pattern. And then what we do when we run this program is we send data to the sound card, and it kind of produces sound waves. So there's so suppose it's a short pattern. Well, what ends up happening then is that we kind of go beep, 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 beep. We kind of produce this pattern in rapid fire. It has kind of a frequency, it's a high frequency, right? That hits our ear and causes a vibration that we perceive as being a relatively high pitch because of how often that pattern is hitting the ear. If we had a guitar string that had a much longer sequence to it, then as we send that to the sound card, we kind of get boom, boom, boom. This kind of gets sent to the ear, and it causes a different vibration in the ear that's perceived to be a different pitch. So we kind of understand it to be a lower note instead of a higher note. So, what's going to differ from one guitar string to another is going to be, how many things are in it based on its frequency. And another thing that this one simulates is that if you pluck a guitar string, the guitar string doesn't make sound forever. It kind of dissipates, right? There's an energy dissipation. So that's something you're going to have to simulate. At the bottom of the first page, you will find a diagram that, let me tell you, this is one of the single most useful things in the entire assignment write-up, this diagram right here. It tells you a whole lot about what's going on. So what you're going to do with these guitar string objects is you're going to take the first 2 values that are in this structure, and you're going to average them. And there's what's known as a decay factor, kind of this energy dissipation factor. So you're going to take these 2 things to use this little formula to compute a new value that goes at the end of the structure, and you're going to remove something from the front. So we're kind of cycling. We're looking at the front 2, we remove one, and we put one at the end. What does that sound like? Removing from the front, putting it into the back, removing from the front, adding to the back. It's cue-like structure, and I'm asking you to implement this as a cue. So that's the little bit of practice with cues, is that you're going to implement this using a cue. Now, normally with the cue, what I showed you, you'd have to call remove twice to remove 2 things from the cue. And we don't want you to do that. We only want you to remove one of the 2 things. So you're going to have the ability to be able to see what's here without actually removing it. There's an extra method in the cue interface called peek. Peek lets you look at the front of the cue without actually removing it. And you're going to use peek for your homework assignment. So you're allowed to do it for the homework. I mentioned that for the exam questions, we don't want you to use peek because it oversimplifies some of those exam questions. So yesterday in section, we didn't talk about peek because we don't want you to use it for the exam questions. But for the homework, we do want you to use it. So you'll be removing something, peeking at something, computing a value, putting something at the end, and then removing something at the front. So you're cycling through those values, in your guitar string. So that's the kind of thing you're going to be working on in the first part of the homework. When you've reached that point, you will find that you can run this program. So this little Guitar Hero program is available to you, and it has this thing that's known as Guitar Lite. So Guitar Lite is a guitar with those two strings. And if you've implemented your guitar string class correctly, you should be able to get the same two notes that I had a second ago, the A and the C. Now, the fact that there can be different kinds of guitars means that we want to generalize, have code that's kind of written in a more generic way, so we have introduced an interface. So you don't have to write the interface, we wrote the interface, but you're going to be using a guitar interface. So the idea is that there's many different kinds of guitars that could implement this interface. And we are giving you a complete implementation of it known as Guitar Lite. So this is the one that has those two notes, the A and the C. So we give you the guitar interface, and we give you this implementation of the guitar interface that works for just two strings. What you're going to do in the second part is you're going to make something called Guitar 37 that has 37 strings. Now, you could make 37 fields and you'd get a very low grade on the homework. We don't want you to do 37 fields. What are you going to do instead? You're going to have an array. You're going to use an array so that you have an array of 37 guitar string objects. So a lot of what you're doing in the second part is generalizing this code that dealt with two strings and turning it into code that deals with 37. And you'll find that I didn't write loops here because there's only two things involved. You don't need loops when there's only two things, but when there's 37 things, you're going to write it using loops. So that's a lot of what the second part is generalizing Guitar Lite into Guitar 37. So you're going to study Guitar Lite a lot. It's going to be extremely helpful to you because it's an implementation of the guitar interface. And we're kind of, you could see already so many different things. There's an interface, there's different classes and so forth. But one of the reasons that we did that, we said the idea is that I could unplug one of these and plug in a different one, right? It's like my TV where I can unplug the DVD player and plug in the cable. I'm going to unplug Guitar Lite and I'm going to plug in Guitar 37 because I have an implementation of Guitar 37. That's your homework, but I have one already. So I can recompile. And again, this is one of the nice things about an interface, is it makes it easy to just have it construct a different kind of guitar. So this is a Guitar 37. Let me try running it. And let me try to do something I often fail, but let's see if I can manage to play a little bit of music. That is the extent of my ability to play music. But that's the kind of thing that you should be able to do when you have finished implementing Guitar 37. Kevin Wayne is a piano player, so he set it up in such a way that these keys are mapped on your keyboard to work well for piano players. So if you're interested, that's there. There's a lot of extras for this assignment that if you're interested, you can use them, but you don't have to. Let me give you an example. That I have a program called Play That Tune that can play files that have music in them. We have a Record That Tune. If you want to play this and record yourself, you can do that. But we've had students over the years come up with different files for us, like Game of Thrones. Someone did that. So all of these things like Play That Tune, there's a Record That Tune. These are all extras. You don't have to do any of this if you're not interested, but some of you are going to be more interested than others, and if you want to do that, that'd be fun. I'll set up something on the Ed message board where people can submit new songs. If you have your own recording of something that you want to add to our repertoire of songs, we'll have an ability to do that on the Ed message board. And I think we're about to be cut off. So we'll do more next week.